So here we've got our Geotechnics lab. This is the lab that you would particularly use in the Geography and Natural Hazards degree. Within the lab we have a number of different pieces of software and pieces of equipment that would allow you to begin to test soils such as strength, pore water pressure, and begin to classify soils as well. So a couple of examples of pieces of equipment that you might use during your degree. This is our Sieves. These are our lab sieves, and these would allow you to classify soils. We also have sieves that you can actually use in the field as well, so we can take them on field trips with us, and they have very much the same approach of allowing us to classify soils, but we use them in the field rather than in a laboratory environment like these ones are built up to do. You can't imagine us putting these in our suitcases. Around here, just continuing on, you can see we've obviously set up for a number of different things, but we also have the ability to begin to test the shear strength of our soils as well. So this piece of equipment here allows us to gather different samples of our soils, enter them into our system or our piece of equipment, and then test the actual shear strength of that soil, so the amount at which failure occurs along the plane. So these are both the same pieces of equipment, but will allow you, obviously, in your groups, or if you wanted to through dissertations, to test different soils and different profiles of those soils as well. So we're going to continue on. We've got a bit of a round tour here. So continuing over here, we've got our triaxle. Big pieces of equipment, as you can see, not set up today, but our triaxle allows us to again take samples of our soils, to surround those soils with water and to measure water pressure and load pressure, to work out the point at which failure occurs. So our triaxle becomes very important, obviously, in understanding our soil in itself. Continuing down here, we've got our compression tests. So these are slightly different. We've been looking at failure and classification of our soil so far, but within this piece of our equipment, we have our computer that logs our tests, so logs our different compressions. But we would enter a piece of soil into our equipment, we would load that up with our weights down here and work out at which point compression is beginning to occur. And that again allows us to learn more about the soil, more about the geotechnical aspects of our Earth's environment. Now, this is all very important if you're thinking from a geography and natural hazards degree, obviously, because we need to think about the capacity of our soils or the potential for likelihood of failure. So, as a bit of an example, we've got some different soil profiles here that allow us to understand, break down different soils, right through from obviously our more fine sediment to our more conglomerate or large scale sediments. But this is the type of soils that you would use, this type of samples we would give to you, and you would begin to test them on all of these different pieces of equipment to understand that potential for failure or even the strength of that soil. And that would allow us to continue on in our studies to understand things such as mass movements or landslides, earthquake capacity, the foundations and the strength of foundations for earthquakes, and even begin to understand how we could perhaps even build structures better so that in the long run they are able to withstand an earthquake, a hurricane, or even a mass movement event. What we've got here is another piece of equipment, not something necessarily we use in a lab, but we can use this more in our classroom environment. But this allows us to simulate an earthquake or shaking. And as part of this, what we can do is assess or evaluate the integrity of our buildings, building structures, maybe consider how we can improve building structures so they're less resistant to failure during an earthquake, and even for some examples in a tsunami as well. So obviously for different activities or different scenarios, we can have a go at building different structures that might be appropriate for that environment. You can see here that we've got a house, in this case built from wood and paper, that's built on stilts, so somewhere that might be more likely to be affected by a tsunami maybe. but also we need to establish or assess whether it is actually able to withstand shaking from an earthquake. And this little piece of device here, or this piece of equipment, allows us to begin to simulate that. So all we can do is turn up our motor, our speed, and it begins to establish that shaking motion that we would feel during the passage of seismic waves. Obviously, depending on the different intensity of an earthquake, we can increase the shaking that occurs. Down a little bit, you can begin to then establish if there's any particular areas of that structure that might be likely to fail, or anything that you might need to do to reinforce the structure, such as crossbars or rebars, or even strengthen the foundations.